Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve this contact nonlinear analysis. We have taken a case of a simple clamp. Both are having same material of Young's modulus 210 gigapascal and Poisson ratio 0.3. Now we will move into the case. We just want to clamp this cylinder. So here we are going to fix it, this backside surface we are going to fix it, and these two surfaces we are going to apply a 7 mm in minus x direction. This is actually x direction, minus x direction we are going to apply. By applying it both the direction, here we are going to both the side, here we are going to give a contact. So due to that it is going to expand and it will go inside. That is due to moving this side, it will expand and it will generate a reaction force in the fixed side. Our ultimate aim is to find the reaction force due to clamping and contact force also. Now we'll model this and we'll solve this using code aster. This file I have downloaded and kept it here. This is my step file. In this case we'll learn how to import the step file. First open code aster. So here I have kept the salome meca. It is got open. Now we will move into geometry module. First go to file. There is an option called import step. Just navigate the file where you kept. So this is my file. Just open it. Just give no. Because I have modeled in mm, I just want to solve it in mm only. Code aster and salome meca doesn't have any unit consistency. Whatever the unit we are using from geometry, the same unit has to be followed. Just go to, after import, you just check the dimension, go to inspection, dimension, bounding box. So this is my dimension. Now my dimensions are correct. Just close it. Now we'll create the groups to apply the boundary conditions. Just first I'm going to save this file. Go to file, save as. This is my location. Just save it. Now I have saved it. We'll create the groups one by one. First we'll create, this one is a clamp. Just apply. This is actually a cylinder. Just apply. Now we'll go into surface groups. This surface I just want to fix it. Just naming as fix. These two surface, this surface and this side surface, I'm going to apply the displacement of 7 mm. So for that I'm just giving disp. Just okay. While naming groups we should not use any space. Instead we can use underscore. Now we need to specify groups for contact. So here there is contact is going to happen between these two surfaces. The first I'm just making this surface. As master. Just apply. Press the shift and hold, will get, you can able to select this surface. So this surface, just add it. Here also you simply press shift and hold, you can able to select these two surfaces. So this is actually a slave. Here also contacts can happen, so this surface also you can add it. Now this one is slave. Just apply. Now we have created all the groups to apply the boundary conditions. Just close it. Now we'll check the groups. While selecting, we may have selected wrong surfaces. So first one is, this one is clamp, this is cylinder. Here we need to fix it. These two surfaces, we can add these two. These two surfaces we need to apply the displacement. And this cylinder surface is the master. And this surface is the slave. Now we have done the checking. Now we can save this file. Now we can move into meshing. Now we are in the meshing module. Select the contact, go to mesh, create mesh. Now we can simply generate NetGen 1D, 2D, 3D. In this case we are going to use NetGen 3D parameter. Simply just make it 0.4, one more 0, just make it. Instead of moderate, we just make it very fine. Just OK, apply and close. Right click, compute. Based on the surface size, it will generate the mesh. Wherever we need bigger surfaces, it will generate bigger element. Wherever the surface is very small, it will generate small elements. It will optimize from that itself. Now it has generated very fine mesh. Now we'll check the mesh. So this is the mesh it has generated. Here you can see it has generated very fine mesh. Now we can reduce this mesh size. Right click, edit mesh. Because it's a contact problem, it will take much time. I'm just reducing it to very fine into fine. Save OK, apply and close. Right click, clear and compute. Half of the element size is reduced. Now we can see here we need a very fine mesh. It has generated in that way only. Now we can reduce this also. Anyway, we can keep this. This is enough to our model. If you want to reduce the element size, we can reduce further also. I'm just saving this file. This is enough. Anyway, we can go for further reducing the element size. Cancel. Right click, edit mesh. Instead of moderate, we can go apply and close. Right click, compute. One lakh 78,000 element it has generated. Now it has reduced further. Now we'll check the contact area. Anyway, this is enough. If you want to make finer, we can make finer, but it will take much time. For education purpose, we'll keep this mesh. We can move into solving. Now I'm just going to save this file. Now we'll check the element groups. Just hide this one. Here I just want to fix it. These two surface I just want to apply the group, displacement. This one is the master. This surface is the slave. And this is the clamp volume element. And This is the cylinder. Now we have done meshing also. Now we can move into aster studies to create the setup. In this case, we are going to create setup one by one, step by step. So first, right click the current case, add a stage. First we need to read the mesh. Go to mesh, read mesh. So this is the mesh, MAD format. Just apply, save OK. Now we have read the mesh. Then we just go here, we need to assign the finite element. So finite element, click it here, edit, everywhere. This is the mechanic. What type of analysis we are going to do, we need to specify it here. This is mechanic 3D analysis. Save OK. Just apply, save OK. Assign to all. Tout OU is nothing but assign to all. Now we need to specify the material property. So first define the material. Go to the PPT here. So material is steel. We are not using a contact nonlinear. We are not using a material nonlinearity. Only the contact nonlinear we are doing. So material is linear only. 210 e power 9. No, this is in (2.1) e power 5. We need to specify it in mm because our model in mm. It has to be specified in megapascal. Similarly, point sound ratio is 0.3. Density is not required. Just save OK. Just apply, save OK. Now we have defined the material. Now we need to assign the material. Go to material, assign a material. So switch on this mesh and model. Now we need to assign the material to all. Yes means all. Single material. Just say OK, apply, OK. Now we have defined the material and we have assigned the material to the model. Now just go to function and list. What we are going to do is the 7 mm we are going to apply from 0 to 1. Linearly we are going to apply the load. For that we are going to create the multiplication function, that is called define function. I am just naming as load multiplier, load function, coordinate, this is time, just edit it, time to function. When 0 it has to be applied 0, when 1 it has to be applied 1. 0 the load is 0, and when the when 1 the 7 mm is applied. When it is increased from linearly, the 7 mm will linearly will increase and it will apply. So this is the way we are going to apply the 7 mm displacement linearly. Just apply it, just apply, save OK. This is the load multiplication function. Then we need to create the time period. Just go to defi list rail. This is we are going to do static nonlinear. Pseudo time period we need to create it from 0. Maximum time is 1. Pass is 0.1. So 10 time steps we have taken. Just apply, save OK. This time step will be controlled with auto method. There are different methods there, manual method and auto method. If it is not converging any one of the time step, it will reduce the time period in its own. From that it will calculate and it will reconverge the solution. Just apply, save OK. So now we have created the multiplication function as well as the time in which it is going to solve. Now just go to boundary conditions. In boundary condition we need to assign the mechanical load. So first thing is we need to fix it here. So here we need to fix. So there is an option called enforce degree of freedom. Edit, group of element. Actually we need to create a node group also for fix. Now it is got selected. Here you can see the fix is got selected. We can give blockage also. It will fix all the degree of freedom. Blockage of displacement, dx, dy, dz is 0. In separately also we can specify it. Now that is fixed. Say OK. Then one more loading condition is displacement loading condition. Again you just go. We can specify it in the same group also. Anyway, we need to multiply with the load function. For that I just want to specify separately. Save enforce degree of freedom. Edit. Here group of element. Edit. The group is disp. Just save OK. No, we are not specified this one. Here we need to specify the displacement. This is x direction in minus 7 mm minus direction it has to move. Remaining are 0. Just save OK. Just apply it. We can specify other thing as 0 also. These two are 0. Just apply it. Save OK. Now we have specified the displacement group. Now we can save it. Now we have specified the load and boundary condition. Load is 7 mm is the load. The other thing is we need to specify the contact. You just scroll down here. There is an option called defi contact. This is the physical contact boundary condition. Model. Here we need to specify the zone. First one is the slave. Second one is the master. Choose the slave here. Save OK. Here mate is nothing but the master. Chosen. Save OK. Formulation. Continue. There are different method is there. Discrete method, continue method. Contact Coulomb contact means we need to specify the Coulomb value. Default I'm just keeping. Just apply it. Oh, it has changed, so we need to specify again. So go to slave, choose the slave, save OK, and again go here, choose the master, save OK, and just save OK. Continue. Everything we have specified, just apply it. Now contact has generated without any error. Just save OK. Now we have done of creating contact. Just saved it. Now there is no pre-analysis. Just go to analysis, set the solver. Now our solver is static non-line, that is meant static non-linear solver. Time stepping, this one is the time step, just save OK. Here no result structure element loads, just click this loads. We need to add these two loads. First one is load, just save OK, and second one is load 0 multiply with the load function. So here we are applying a displacement, we need to multiply with the load function. The 7 will be multiplied with the load function. Then contact, we switch on this contact will enable here. Just make it this default only, elastic petit. Now it is done, just apply it, save OK. Now we have set the solver. Now just go to output, set the output results, just save the file location. So I'm just giving name as result.rmed. Just click it here, add mesh. This one is the static non-linear. Here there is an option called tut-49, make it S. Just OK. Format to make it MED, just apply, save OK. Just save it. Now we have done of creating setup. Now we can move into solver. Just go to history view. Here I'm just going to specify more memory. Time also I'm going to specify some 50. Now just click this plus button, 5 seconds, just run the case. It will take some time to finish the solving. If any error comes, we can see it here in the message file in output format, and we can go and edit the setup and we can solve it. Now it started solving. Now the solver is taken. The first iteration is going. We have to check the convergence every iterations. If any one of the iteration is diverging, it will go out with an error. We need to modify the solver. We need to rerun the case. We have given only the displacement. It will calculate the primary variable of displacement. Other thing it will not calculate. If you want to get it stress everything, we need to recalculate. We need to rerun the case with that value. Some directional stresses, one meter stresses, that is we can rerun similar to ANSYS, and we can get it from the result file and we can solve it. We can take yes, now it is solved without any error. Now the files are saving. Now it is solved, you can see it here. Now we can open the file with paraview. I'm just saving this. Go to paraview, just open it. Pictures, code aster, the result RMD. Here you can see contact and displacement, it's coming. I just want to see the displacement first. So it is not read complete data, just first read all the values. Now it is read. Just go again. Now you can see it here. So the green color is -7 is going. Okay, it's correct. These are all correct. Okay. Why this is coming? Okay, leave this value. Just go to dx -7. Just simulate it. So it will not go. Just generate the vectors. Just apply it. This one. Just apply it. Now just simulate it. Yes. Here you can see, due to the contact, it is getting enlarged and it is yes. Now it is solved very nicely. Now we can check the other values. This is the displacement we have applied. It is done. It is taken very nicely. Now we can check the other values, stress, everything. Just delete it. Delete this also. Now just go to aster study again. The only thing we have calculated only the displacement at the first run. Now we'll calculate directional stresses and von Mises stresses with the new run. Just go to the case here, just click it here, add one more stage. Here go to post processing, use the calcam to calculate the other value. Here there is an option called reuse the input with the object. Just make a tick and constraint switch it on, criteria switch it on, and force switch it on. In constraint we need to choose sigma element and sigma node. In criteria you switch it on equivalent element and equivalent node. Here you switch it on reaction node. Every time step we need to calculate. Just apply it. Now this thing we need to calculate. Same name I have given. Now we need to save the file. We can save it the same file also. I just want to save it as another file. Set output results. Give some another name. Pictures. Code aster. Contact. This one. Result 1.rmed. And here you just go plus add mesh. Here you just choose call champ. There is an option called tut-49 SOUI. This is make it S. We can specify separately by one also. This is the easiest way of specifying. All the result has to be saved. Just apply. Okay. Now we have done. Just save this file. Go to history view. Select this one. Here there is different option, you can see it. This is actually a run. If you are clicking plus and giving run means it will run the case. This one is the skip the case. This one is the reuse the case. What my case is, I just want to reuse the previous result file to run for current case. Take the previous file and calculate the stress, directional stresses, von Mises stresses, everything. So for that you just make it box into tick. So what it will do, it will reuse the previous file and make it this one is plus. So it will take the results from previous case and it will solve the stress value. It will calculate the stress values. Okay. So now 5 seconds, same data, just run it. So whatever we are doing in ANSYS we are calculating initially with a displacement. If you want to calculate some other things means we can select the value on rerunning it. Same way we can do it here. See, it has calculated. So it has taken the file and now it is calculating the datas. Now copying results are doing. See here, copying result file and copying message file and bash file, everything it is doing now. Now it is diagnostic job is okay here. It has to update here. Just wait for a while, it will get update with the green. Because it will take 5 seconds to update. See, now it is solved without any error. Now just save this file. Now again go to paraview. We can check the stress values. Just go to paraview. This is the current file. It includes displacement also. Now the previous file is not required. Just open, apply it. Now just go to displacement. Now we need to read the complete data. Anyway, previously we have read it out. Now just go to one by one. Stress values. Stress values. Now just go to displacement. Here we can go for generate vectors, apply it, wrap by vector, just apply it. Now our displacements are correct. Just go to see the van Mises stresses. So this is the van Mises stress value. Now we can set the color legend as blue to red rainbow, and we can make it into 12. So red is coming here around 800 to 926. We can rescale this into 800 to sorry. So this is the way stress is. Here the stress is getting higher, more than 600 we are getting. So this 600. So van Mises is 600 megapascal. Go to van Mises stress. Now just simulate this value, you will get it. So while going here, this is expanding and getting compressing, like that it's doing. Now we have completed our case. We can simulate one by one. The third iteration, it's getting more stresses. So thank you for watching my videos. The case is finding reaction forces. To get the reaction force, we need to run the case again That is, we will see it in the next any one of the small tutorial. So thank you for watching my videos. Please subscribe my channel for more videos. Thank you.